Hi there. I'm going to be doing a format walkthrough of the .cam file for Resident Evil 4 Ultimate HD Edition for the PC. I've been working on the file format for a little bit here. A lot is still unknown, unfortunately, which is sad. I think a lot of it has to do with just us going into the game and just tampering with some file numbers in the file until we can actually understand all the meanings that they have, which is kind of a laborious job to have to go through and check everything out. But I'm going to explain what we know. Before I get into that, I want to be transparent that the .cam file has subtypes that change the entire file completely. So the extension .cam doesn't actually represent what's inside the file. Okay. So the first type that I've identified is the EMPT, which I would imagine is a legacy format left over from when the Resident Evil 4 engine was used for Resident Evil 1 Remake. So you can see the data is usually left blanked. Probably it's an abandoned file type they just left in there by mistake. So that one, I don't think we have to worry about that one. The next one is the B403. I haven't actually sat down and actually picked this one apart yet. It's very seldomly used, so I haven't bothered with it. But I would imagine it still has to do with cameras, and it's probably similar to the B404 that we'll be looking at. So this one I don't have any information on at this time. All right, so we're actually going to be looking at the CAM B404 file. We'll kind of break that down as much as I can. All right, another thing about this format is there is another table in here that I don't understand a lick about, so I'm not going to be discussing that in this video. The table is relatively easy to read. I think it's 16 bytes per entry and just contains a bunch of zeros and ones, possibly linkage to other files. I don't know. It doesn't seem to be present on all CAM files. Only a few. All right, so let's break this down. I made a color block out for this file. The B404 is the most common CAM file you'll see in the stage files. So it does afford us a lot of fun editing. I wrote a tool to visualize this in 3ds Max by making boxes and cameras. And this is representing what's in the CAM file. One of these boxes is a zone where you would enter the area and it would trigger an event, and that could be to activate a camera, or it would shoot and look at something. For example, if you were to find, I don't know, item on the ground, and the camera would take over and zoom up on the item. So interestingly, that's controlled by a zone, a walkthrough zone, as well as a camera. So the data in the file is represented in such a way, and I'll explain that with a picture. Actually, I don't really like that picture, so we're going to redo that one. Nope. Oh, I gotta redo this, my bad. Alright, I'm gonna redo that picture, because it just doesn't look nice. Alright, so let's do this. Okay, so we have, in the CAM file, we have this governing file entry, which is going to be called Table 1. Alright, Table 1. In Table 1, what it does is it contains a list of 2 pointers, and the pointers can point to 2 types of data, as we so far understand. And those 2 types of data are the zones and the cameras themselves. Alright, so that's how that table works. So for each entry in the table 1, they will point to camera data and zone data. Now it's optional that this table actually contain any pointer. In some cases it doesn't even need to have a pointer to camera data, because the zone might actually be controlling something else in the entirety of the stage. So what's interesting about this file is, yeah, it does seem to be pioneered for camera data, but optionally it can actually point towards another file in the system, so this zone acts as a trigger for something else. So the format's actually a little bit integrated itself into the map as a whole and its function to the map. But anyway, we'll be treating this as strictly a file that controls zones that you enter that then trigger camera interactions. Alright, so let's talk about that. So I got this blocked out so we can start discussing this. There are basically, actually let me go back in here and do one more diagram so we can understand this. Alright, so the entire format seems to be blocked up this way. So we have the header, whoops, wow, that went back too far. We have the header. Alright, sorry, that's sloppy. We have the header, we have table 1, I'll just call it T1. We have T2, T3, T4, and then we have the heap. Alright, so a heap is basically what you consider just a pile of data. You just throw stuff down there. So if T1 decides, oh hey, I want to store some stuff, it just throws it down the heap and it just sits on the bottom. Same thing with T2. Oh, I got some garbage for you too. Here, take some of that. Oh, I don't want this. I gotta take a dump. So this stuff is just a bunch of dump from the ascending tables. This stuff is very important because sometimes they'll dump camera information or the positions for the trigger zones. So the heap is very dynamic in its structure. So what we need to do is we need to read the structure in the aforementioned tables in order to retrieve things from the heap. So we're talking about these blocks. We're talking about the header, table 1, table 2, table 3. In this exercise, we'll be ignoring table 4 because I don't understand it. And then we have the heap, which I'll briefly discuss a little bit. Okay? Alright, so let's go with the color code. So we have the first one. This is the header. The header is always the same size. It's 16 bytes in length. We have the first 4 bytes, which is our 4-character code identifier. In this case, it's called the B404, which identifies its file type. Then we have a bunch of bytes that describe the counts for each table. So we have the first here is actually how many cameras are in the file. Okay. The second is how many trigger zones are in the file. Now, consequently, the table 1 and table 2 have the same count, from what I can tell. 2 would control both of those tables. Seems like every entry always has to have at least a trigger zone, walkthrough zone attached to it. So 2 seems to control both counts for those tables, 1 and 2. This one here is actually for table 4, but table 4 is not here. The table 4 only shows up on some files, and its function is not clearly understood. Right, the remaining bytes from 7 to 4 are not observed to do anything, so we're going to ignore those. They can be considered just reserved space or padding space, which just terminate at F. Alright, next we have the table 2. Of course, we have 2 entries. I have it labeled here in green and blue. Okay. So this would be our first entry, and this would be our second entry. The table seems to be relatively simple. We have we would say here, a byte here, number 4, which seems to describe the type. After that is not understood what these bytes do. We can consider them to be leftover, reserve, padding, whichever. Next we have 4 bytes that make a 4-byte long integer, and then after that we have another 4-byte long integer. So this 4 bytes here we can call the pointer to table 2, and this last one we can call the pointer to table 3. So this tells us where the data for our walkthrough zone or trigger zone, we want to call it, is located, and this one tells us the address of where the camera data is located. So if I look at 30, I look at my address bar over here, 30 is right here, and I've colored that in orange. And you can see on the next entry, it's saying 60, which is as well underneath this one. Okay, so we'll talk about the second table. So this is table 2. Okay. Of course, this is 48 bytes per length or per entry, so we have 48 here and 48 here. Okay. Again, this is described in the first table, table 1, as to where each one of these is located. So we have 30 and 60. Okay. So let's talk about the first entry in table 2, because now the data starts to get a little bit more cramped. The first 4 bytes here are interesting. They are a linking table, which actually links this file to other files that are packed together within the DAS or UDAS, which is the stage resource package. Not much is known about this data structure. I believe the only thing that is currently known is that this number 2 byte is connected to the LIT file, which controls the light zoning and activation in the stage. The other 4 bytes, I think we link those to defaults. As we can see here, this is always 1. This one's always 0. I think 4 we had linked to some other number in the file. I think this 4 or something we had linked there. I can't remember. But this is not really understood. As well, going up to here, we do understand that these from 0 to 8 have some importance. Sorry, 0 to 9, but they are not clearly understood. So a lot of testing is required to actually understand each one of those bytes, so we can understand what those is, what those do. All right, so going from there down to, I believe, I believe down to here, we don't know what that stuff does. So basically, the whole table we don't understand. It sounds pretty bad, but I have a hunch that from A down over to here, it's probably not used. I believe we did an experiment where we just wrote in a bunch of FFs, and it didn't really have any impact on the gameplay. So I don't think those would do anything, so I don't think I have to worry about those. Alright, so we're going to skip down here because honestly I don't know what those do, and this stuff we know a little bit more about, so it's not so bad. This byte here is the, as we understand it, it's the height of the trigger box. So we have a trigger zone, we want to call it walkthrough zone or whatever. Well, this zone has a height to it. Actually, wait a minute, I got that backwards. Just check that real quick. Give me a moment. I probably have this backwards. Okay, so I called that 057. Okay, so, okay. Yeah, that's correct, that's the height. And then the next value is considered the position. So for example, this starts from the bottom. So that would be the bottom, and then this would be the height above that bottom. So that's what that is. So if I had to illustrate that, give me a moment here. If we draw a box in 3ds Max, okay, so this is our second value, our bottom position, and then we were to then move our mouse up. I should have moved my mouse up, my bad. Alright, when we create our bottom, and I move my mouse up, that's the height. So it's growing up from the bottom up. So this is our height, and this is our position for the bottom. Alright, this one over here is the count. 4 seems to be the count for how many vertices are in our shape. So right now, if we take this box, we have 1, 2, 3, 4 vertices. And then what we're doing technically with the other values is just growing the height. So this is how many vertices or sides that you have. Okay, and then this is the pointer to that data. So if we follow down to F8, that would be here. So what it's saying is it's defining an x, y, z value for 4 corners or 4 vertices. So that would be x, y, z, x, y, z, x, y, z, x, y, z. And this would be one zone for our first entry. Okay, and that takes up a fixed size of, what is that, 30. Okay, now it's going to change based on that count. If it goes up to 5, then it'll take one more, X, Y, Z, and it'll increase that amount of data used in the heap. So this down here, sorry, is the heap. That means whenever it's, has data that falls outside of the fixed size, it just dumps it down here. So any dynamic data is just tossed in the bottom in the heap. And any fixed size variables seem to be just fixed inside of the head one of the tables. All right, so we identified this. So if we jump down to the second entry in table 2, we have the same thing here. Okay, on the bottom we have our height, our Z position, how many corners, and then where we can find the corner data or the vertice data. And so this one's at 128. So we can see here 128 starts right after the second zone. And of course that would be the same size, it's 4 as well. So this is our zone 2. Okay. Alright, so that concludes table 2 and what we so far understand about it. Next is table 3. Table 3 is similar, where in the fact that we don't really understand much about it. We have these counts here, 1, 1, 6, 0. Again, it seems to have some kind of tie-in with the relation of other files. We do understand that this value here is the identifier for the camera. Now, for some reason, it doesn't start at 0, which is strange, but any value higher than 0 assigns an identifier to this camera. So this, again, is table 3, that's camera data, and each one of these will have a unique number on them, and that identifies what they are. It's like an ID. So this is camera 1, and we would call that camera 1. That's basically how that would work. The next byte is the type of camera. We have identified about, I think, 8 types of cameras. Give me a moment, I'll find information on that and provide. Okay. Alright, I don't have examples to show in this video of the different camera types, but I'll explain what my notes, I've written down for my notes. So type 0 is a camera that is locked to a particular position and rotation. So it's a fixed camera. You set it up, you enter the area, and the camera will look at something as long as you're in the area. Type 1, camera aligns to, sorry, I shouldn't have done that. I'll go back here for a second. I'll just show you my notes. You don't need me to explain everything. Yeah, here are my notes. So we have the 8 different cameras from 0 to 8, and they all have different attributes. When you enter the area, that's defined, the zone, and it will basically manipulate or take control of your camera. And each type seems to have a different behavior, many of them being scripted. So when I mean scripted, a camera will have a certain behavior that's not defined by the cam file. It's pre-programmed. When we call it in the cam file, that pre-programmed camera just gets called. So for example, this one, the camera aligns behind the player, and FOV pulls back as the player passes. So it's an interesting camera because it's designed for Resident Evil 1 Remake, as if you were to enter a narrow hallway, and the camera is doing these very elongated, scary pullbacks on the player. So we see a lot of interesting camera behaviors that camera can control or call upon. All right, so that's the type, and then after that, I believe all of this is not known. From here on is not understood. This value we have been setting to 1. Again, we don't know what this is. It might just mean to activate me on all of these things here. But we've been setting this for 1. This we know is the identifier, and then we have the type, and then from here on we don't know what it does. Okay, after that we have a address, a pointer. This pointer points to, interestingly, the end of the table, and this produces the camera animation speed. So it's not clear as to what the rest of the data here could be. It's possible that these are reserved for other pointers. So far we do not understand what that does. Alright, so this pointer here will just follow this down, even regardless that it goes to the bottom. So let's say it goes to 100 and D8, so that's over here, of course, yes. So we go based on the count. That's how many things we'll be reading, so the count would be below it, so the count here is 2. Alright, so we go down here and we need to read 2 short values. So that's 1, 2, that's a short, another 1, 2 is another short. So we're reading in total 4 bytes. Okay. So what's interesting is the count. You would think it would have been higher up in here, but the count is actually set in this area, which is just below. So we need this count in order to read the data at this pointer first. So just keep that in mind. Alright, so moving on, we don't know what this does. Potentially other pointers. And then we have the count. Alright, the count is how many data that you'll see repeated in the heap. Alright, next pointer, technically the second pointer. However, these could be other pointers. So this could actually be the 5th pointer. We don't know. But the next pointer here points to 158, which is here, which is right after our zone data. Now this seems to have kind of a preset, I mean the pointers all seem to have a, what was I going to say is a defined behavior or defined data that's associated with it. So this, this over here we know that is involved with the animation speed. This one we have identified as involving the camera position. This one we've identified as controlling the camera direction. So there is a, I'll illustrate this. If we create a target camera, we create a camera and we create a look at position. This is where the camera will follow. In 3ds Max it's called a camera target. And what this allows us to do is take the camera and move it, but retain the camera's we would say focal point, where it's looking at. So that would be the camera look at position, okay, or target. That's what that does. The next one, I think this has to do with the camera zoom. That's not really understood that well. And then this one we believe to be associated with the camera's FOV, its field of view. So if we were to demonstrate that here, the field of view is how much the camera can see, and this distorts perspective. So we can see everything or not much. So if we were to dock this camera, oh, which camera is this? This is camera 1. This one. Alright, and if we change the FOV, you can see, you know, it kind of controls the zoom, I guess. Okay, so that's what these pointers all do. So I'll just follow along and kind of show you what some of them do. So we got this one goes in between around here. Because we have 2 data records, it's going to have a position for the camera, but it's going to have 2 positions. So we have X, Y, Z, that's the first position. X, Y, and Z, that's the second position. So overall, it would use up about this many bytes. Okay. So the second one is at 170, so of course that's right after this one. Again, it would be XYZ, because we have 2 frames, or 2 on the count. So I'll just color that real quick here. And the next pointer we have is 188, which is this one. This one seems to control the zoom, and it seems to store 2 floats. Again, it's a single float, but per count, so we have 2. So there would be 2 floats here, is what I was saying. I'll just color that. And in most samples, pretty much all the samples that I've checked, is always 0, so I'm not exactly sure what this field actually does. The last pointer, 190. This controls the FOV. So FOV typically stays the same, around 45. So you can see here it's about 47. Yeah. So again, we have the count 2, so we would go FOV1, FOV2. I'll just color that in some other color. Alright, so that's pretty much it. The next entry in our table 3 would probably start right here, We can check that. So there's our table 3. Starts at 198. Of course, that's where it starts. So we probably go the same size. This one is about, what do we, I think we started here, I want to say. Oh, this is the zone. Sorry, that's where this starts. This is table 3's, so the first entry in table 3, this is the entry data in the heap that it had deposited. It's about 64 bytes. So we follow that down for the second entry, again 64 bytes. We're left over with this remaining data, and that's where, again in table 3, this other pointer, we can call that the first pointer, is depositing its stuff on the very end of the file. It's the very last thing that gets dumped, and that's the playback speed or frame rate. So it's saying at 100D8, which is, this is here, again times count, so that would be 1 entry, 2 entries. And then our second entry in the table, again, its pointer for that area is 100DC, which is here. And that's the entire file. That's how we read it. So that's a breakdown of the format. Not exactly understood about everything. We still have a lot of unknowns. But at least we are able to parse or read through the data and collect it and rewrite it in the file. So that is a breakdown of the file format. Thank you for watching, and take care.